Welcome to Math 10B again. This is lecture number 9 about binomial probability distribution. At the end of the session, you should be able to, number 1, define what's a binomial experiment, compute the probability of a binomial random variable, and number 3, compute for the mean and standard deviation of a binomial probability distribution. Binomial probability distribution is one example of, or is a special type of a discrete probability distribution. For lecture number 10, we'll talk about one of the most useful continuous probability distribution, which is the normal distribution. But for now, let's talk about binomial random variable first. So this is the definition of a binomial probability. A binomial probability distribution is a discrete probability distribution whose random variable represents the number of successes of a binomial experiment. So what's a binomial experiment? A binomial experiment is a random experiment which consists of a Bernoulli trial. So what's a Bernoulli trial? A Bernoulli trial is a trial with only two outcomes. So success or failure. Bernoulli trial is named after one of the members of the Bernoulli family. It's after Jacob Bernoulli. It's a trial with only two outcomes, success or failure. So for example, toss a coin, dalawa lang pwede mangyari, either heads or tail. Nagsagot ka ng exam, nagsagot ka ng isang item sa isang exam. So dalawa lang pwede mangyari doon, it's either tama ka or mali. You inspect a particular shipment, it can be defective or not defective. For example, you have a bag which consists of red balls and green balls. So when you get one ball, it's either red or green. Or even though yung urn mo mas madami, yung bag mo madaming laman, may red, may blue, may white, may gray. So but still you're interested with red, you can still make that a Bernoulli trial by redefining your elements. So ang mangyayari doon, your success will be getting a red and your failure will be getting a not red. This time, let's have the properties of a binomial experiment. We will consider a binomial experiment as a random experiment. Remember, random experiment. It should have well-defined outcomes, repeatable under the same condition, and unpredictable or within elements of randomness. And we have three properties. The first one is each trial of the experiment has two outcomes, success or failure. Or you can reduce that into two trials only. Or you can reduce that into two outcomes lang, redefining the outcomes. Number 2, it consists of n independent trials. That is, the result of one trial does not affect the other trial. If you toss a coin for 4 times, the first toss does not affect the second toss, or the occurrence of the first toss does not affect the second toss, and so on. Say for example, you have a bag which consists of red and green balls. So pag bumunot ka ng isang ball, then it should be understood that it should be with replacement before you get the next ball, because if you don't put it back, then the sample space will change. So in that case, the trials are not independent. So for binomial experiment, it's understood that those types of experiment is with replacement. And lastly, number 3, the probability of success, denoted as P, does not change from trial to trial. It's constant from trial to trial. Well, because it's independent, no? Now, let's investigate whether these examples are binomial experiments. For example number 1, consider a random experiment of tossing a coin 4 times and let the random variable x be defined as the number of times a head occurs. So our random variable of interest is the number of heads. Thus, these experiments show the properties of a binomial experiment. So let's go back and recall. The first property, it should have only 2 outcomes. The second property, it should consist of n independent trials. And the result, and the independent trials. And the third one, the probability of success does not change from trial to trial. Okay, note that, first one, there are only 2 outcomes. Siyempre, pag nag-toss ka ng coin, it's either heads or tails lang. So yung success mo yung head, and then yung failure mo yung tails. The experiment consists of 4 identical independent trials. Siyempre, yung pag-toss mo ng coin, the occurrence of the first toss is not affected by the occurrence of the second toss. And the third one is the probability of getting ahead is the same, or it's constant all throughout the trials, which is 0.5. So in this case, yung tatlong properties mo ng binomial experiment is satisfied. Thus, this one, example number 1 of tossing coins 4 times is actually a binomial experiment. Your random variable of interest can assume the values of 0 up to 4. Pwedeng 0, wala kang heads, or 4 na heads. Let's have example number 2. Consider a valuable player who serves 10 times on a training. The service is said to be in if the ball passes over the net and lands inside the opponent's court. Let the random variable y be the number of in services or good services. Can this be considered a binomial experiment? Well, let's talk about the 3 properties. The first one, will there be 2 outcomes? Well, in this case, yes. In lang or out. Tama. Invaluable naman. In lang naman tsaka yung out niya. Pero yung definition mo ng in dito, well, pag nag-serve ka kasi ng bola sa volleyball, there will be infinitely many possible outcomes. Tumama dito, tumama sa isang space, tumama sa poste ng net, something like. But for this case, we'll just consider one outcome. In this case, we call it in. If it went over the net and it lands inside the opponent's court. So, kailangan pasok siya dun sa mga antenna, went over the net and inside. So, that's in. Otherwise, it's outside. So, that's our success. Getting in, getting over the net, getting inside the court. And then, everything else is a failure. And in this case, we have 2 possible outcomes lang. The second one, the experiment consists of 10 identical independent trials provided na hindi napapagod yung nagsiserve. Okay? Kasi, baka sabihin ng iba sa inyo, nag-service na ng mga 5 service, no? Yung pang-anim na naapektuhan na naapekto kasi napagod ka na. But in this case, provided na hindi napapagod. And then, number 3, the probability of success, that's getting the ball inside, is the same for each trial. Syempre, isa lang naman yung nagsuservice. Again, provided na hindi napapagod, hindi na babago yung kanyang stamina. And in that case, we have a binomial experiment. Oh, by the way, your random variable of interest, which is the number of good services, can assume any of the following values from 0 to 10. 0, ibig sabihin walang na ipasok. 10, lahat ay pasok. Okay, let's now talk about the binomial probability distribution. The probability distribution in functional form of a binomial random variable x can be expressed in general as this. Okay, masyado ma-intimidate dun sa mga notations. Okay, so this is the probability. The probability of any value of your random variable is equivalent to n combination x, so this is just ncx. P raised to x, that's the probability of success, raised to x, kung ano yung value na hinahanap mo yung probability. And then 1 minus p, so that's the probability of failure, raised to n minus x. Your n here is the number of independent trials. X here is yung kung ano yung value na interested ka. And your values can only assume these values from 0 up to n. So, yan. So, this is our binomial probability distribution in functional form. Now, let's go back to example number 1. Again, we are going to toss a coin 4 times. So, in this case, our n is 4. And then, the probability of getting ahead is 0.5 and getting yung failure natin, yung getting a tail, is 0.5 also. Yung formula natin, yung general formula, which is this one. General formula to ha. Pwede din palitan yung mga n natin dyan para maging siya. Parang specific lang. We can change this n and the p para maging siya. Specific siya sa isang random variable. So in this case, we will change the n since we have 4 independent trials so that your n will be 4. And then your p is 0.5, probability of success, and failure is 1 minus p, it's still 0.5. So in this case, this formula over here, including this, because you have to define what are the possible values for your x. So in this case, we have 0, 1, 2, 3, 4. And this is your probability distribution in functional form. Let's now compute the probability distribution in tabular form. So sabihin, isa-isa natin ko-computein yung mga probabilities nitong mga values na to. Let's start with 0. So for 0, all you have to do is to substitute 0 to all of the values of x. So in this case, 0 yon, 0 yon. You can simplify this as 0.5 raised to 0, 0.5 raised to 4 equals, kinuha ko na siya, it's 0.0625. I also computed for 1, for 2, for 3, and for 4. And I was able to get these values. And then all you have to do is to organize them in a table that look like this one. So this is your probability distribution in tabular form. Again, your random variable of interest is getting, the number of heads when you toss a coin 4 times. Let's have example number 2. Now, consider Mark, a valuable player who serves 10 times on a training, katulad nung kanina. The probability that Mark's service will be inside or in is 0.8. Let y represent the number of times Mark's service is good. Calculate the probability that, number 1, exactly 7 services will get in. For number 1, we need to compute exactly 7 services will get in. Probability of getting exactly services will get in. So we have n equals 10. Your probability of success, that is getting the ball inside. P that is 0.8. So we also know the 1 minus P, which is 1 minus 0.8, which is 0.2. And we are interested with probability of getting exactly 7. So all you have to do is to substitute that in our formula. So I'll put the formula here. And all we have to do is to substitute everything. So probability of x is equal to 7. Let's substitute. We have 10 independent trials, so that will be 10 combination 7. Your probability of success is 0.8, 0.8 raised to 7, and 0.2 raised to 10 minus 7, that's 3. And let's get your calculator to solve for this one. So that will be 10 combination 7 times 0.8 raised to, 7? And then 0.2 raised to 3. Sorry, it should be have a times there. 0.2 times, yeah. So the answer is 0.20. Approximately 0.20. So the probability that exactly 7 services will get in is 0.2. Let's have number 2. At least 1 service will get in. So that's probability of at least 1. So it should be greater than or equal to 1. Oh, alam na natin to, diba? We know that if we want this type of probability, the at least 1 probability, all we have to do is to get 1 minus the probability of getting 0 equals 0. Okay? So in that case, it will become 1 minus what's this? Probability of getting 0. So all you have to do is to substitute your x here and your n, which is 10. So that will become 10 combination 0. Your p is 0.8 raised to 0 and 0.2 raised to 10. Okay? And let's get your calculator again. Edit na lang natin to. This will become 0, 0 to, and then yung 0.2 that will be 10. Okay, so the answer is very, very, very small, no? Very, very small. Parang 0 na lang din, no? So it will become 1 minus, very, very small, no? Ilang zeros yun? 1, 2, 3, 4, 5, 6, 7. Very small. 1 minus 0.0000, something like that. So the answer is 1. It's approximately equal to 1. So ibig sabihin nun, the probability of getting at least 1 service will get in is almost a sure event. Okay? So sure ka na may papasok si Mark na service, at least 1 service. So it's a sure event. So that's for example number 2. Katulad din sa random variable natin for lecture number 8, we also would like to compute and interpret the expected value or the mean and the standard deviation of your binomial probability distribution. So in this case, the mean or the expected value of a binomial random variable x can be computed using your old formula. You can use this. X times the probability of x and then get the summation, which is also equivalent to this one. All you have to do is to multiply that by n and p. Well, intuitively, you can think of, katulad kanina, yung kay Mark, yung probability niya na mag-i-inside yung kanyang service will be 0.8. So, kung nag-try siya ng 10 times, so you're expecting to have 8, tama? 8 out of 10. Or it's just n times p. So in this case, it's like that. Okay, but if you're interested on the derivation of why the formula for a binomial random variable is just NP, so I will just I will just give you the link to the video for the derivation. For the variance, it will be NP times 1 minus P, or NP times 1 minus P. But you can still use our formula for variance. This should be squared, okay? But this is easier. NP times 1 minus P. And then get the square root for the standard deviation. Let's talk about example number 1. For example number 1, gamitin muna natin yung table and let's use the formula that we learned from lecture number 8. So, multiply natin isa-isa. 0 times 0.65, 625. So, we have this one. 1 times 0.25. 2 times 0.375. 3 times 0.25. And 4 times 0.625. The answer is 2. So, the expected number of heads. Well, anyway, ano nga yung example number 1? Example number 1 is tossing a coin 4 times. So, what is the expected number of heads? Well, in that case, you can just use the formula n times p. The probability of success is 1/2 times 4 trials. So, we are expecting 2 heads for every 4 tosses. This means that in the long run, if we do the experiment of tossing a coin 4 times, a large number of times, the average number of times a head occurs is 2. How about the standard deviation? For the standard deviation, you can use the formula NP times 1 minus P. So in this case, nawala na yung equals dito, it should be 4 times 0.5 times 1 minus 0.5, which should be 0.5 also. So 4 times 0.5, that's 2 times 0.5, that's 1. So your variance is 1, and your standard deviation is square root of 1. So that's also equivalent to 1. So how do we interpret that? In the long run, the number of times a head occurs in tossing a fair coin 4 times deviates from its mean of 2 by 1 on the average. So pag nag-toss ka ng coin, either isa lang yung heads, or maglalaro lang siya sa 1 or 3. Pero majority 2. Let's have example number 2. Madali lang. Yung kay Mark, the number of independent trials is 10, and the probability of success is 0.8. So therefore, the probability is, the mean or the expected value is 0.8 times 10, which is 8. So in this case, we can expect, katulad sinabi ko kanina, we can expect to see Mark make 8 good services out of, on the average, or in the long run, kung patuloy niyang ginagawa yung practice na mag-service ng 10 beses. For the standard deviation, it's square root of NP times 1 minus P. So, 10 yung independent trials, 0.8 yung probability ng success, at saka 0.2 naman yung probability ng failure. So, it's approximately 1.26. What does it mean? If Mark will do a large number of service practices, that is, serving 10 times, we can expect the number of good services to deviate from the mean of 8 by 1.26. It should be deviate. But why is it deviation?